This video will switch to English at this time marker. You can check and activate English subtitles below for bits that are not in English. السلام عليكم. هذا اللقاء أغلبه باللغة الإنجليزية، ولكن بإمكانكم تفعيل الترجمة التحتية أو السبتايتلز في يوتيوب عن طريق الضغط على هذا الزر أسفل الفيديو في يوتيوب واختيار اللغة العربية. ضيفي اليوم هو الدكتور نزار ابراهيم، هو عالم تشريح يدرس التشريح لطلبة الطب والأحياء، وهو كذلك عالم مستحاثات وأحياء تطورية في جامعة ميرسي بديترويت، وقبلها كان في جامعة شيكاغو، وهو كذلك مستكشف في ناشونال جيوغرافيك، له كذلك لقب تيد فيلو، وحصل في 2015 على تصنيف في لائحة كرين لأكبر 40 شخصية بارزة عمرها أقل من 40 سنة في شيكاغو. حدثنا الدكتور نزار ابراهيم في هذا اللقاء عن اكتشاف فيه الرائع الذي ادى الى اعاده صياغه المقررات الدراسيه بخصوص الديناصورات. هذا الاكتشاف الذي صنفته ناشونال جيوغرافيك كاحد ابرز 20 اكتشاف علمي في العشر سنوات الاخيره. تحدثنا مع نزار عن كنوز المستحاثات الموجوده في المغرب وعن مآلها. تحدثنا عن الصوره الكبرى التي يرسمها علم الاحياء والتطور والمستحاثات لمكان البشر بين الكائنات الحية الأخرى، عن الزمن الجيولوجي العميق وعن تاريخ الأرض الموغل في القدم 4 ملايير سنة. تحدثنا عن أهمية المتاحف والثقافة العلمية. قمنا كذلك بجولة سريعة في مختبر نزار، حيث عرض لنا مباشرة عددا من المستحاثات في مختبره، بما فيه مستحاثات من تطور الإنسان وكائنات أخرى. تكلمنا عن الفرنسية مقابل الإنجليزية كلغات للتعلم في عالم اليوم، وعن التعليم بصفة عامة، وكثير من المواضيع الأخرى. قبل اللقاء أود أن أشكر جميع مساندي القناة في موقع باتريون. بفضلكم يتم إنجاز فيديوهات هذه القناة. للانضمام لعائلة مساندي باتريون الرابط هو هذا patreon.com/نجيب أم. أود كذلك التوجه بالشكر الجزيل للفريق الرائع للمترجمين الذي قام بترجمة هذه الفيديو إلى اللغة العربية كما في السبتايتلز أدناه. أترككم إذن مع اللقاء. نزار، مرحبا. انت عالم ديال المستحاثات، باليونتولوج ديال التشريح المقارن في يونيفرسيتي اوف ديترويت ميرسي. كنت قبل منها بوست دوك في جامعه شيكاغو. درتي مؤخرا واحد الاكتشاف رائع في المغرب اللي يهضروا عليه وسائل الاعلام، واللي يمكننا نقولوا انه صحح الكتب المدرسيه في العالم على الديناصورات. الاكتشاف كان بخصوص واحد الديناصور اللي سميتو سبينوزور، وتعتبر من طرف ناشونال جيوغرافيك كواحد من اكبر 20 اكتشاف علمي ديال هاد 10 سنين اللي دازت. وكنت ناشونال جيوغرافيك اكسبلورر، وعدد من الحفريات ديالك كتمولها مؤسسه ناشونال جيوغرافيك. داكشي ديال انديانا جونز في الافلام. انت كذلك تيد فيلو، ماشي هذاك تيد اكس، ولكن التيد اللي هو ذا اوريجينال فيري بريستيجيوس سيلكتيف كونفرنس. غادي نهضروا على الاكتشافات ديالك وعلى الجوانب العلميه بالتفصيل، وغادي نهضروا حتى على الوضعيه ديال المستحاثات في المغرب، الكنوز العلميه اللي كاينه في المغرب واللي كيهضروا عليها الناس بزاف، فين هي الكنوز. ولكن قبل من هذا الشيء درجه شويه، شحال البورسونتاج اللي فهمتي من هضرتي؟ واش كتفهم شويه الدارجه كيفاش داير الامور؟
غادي نقول شي 75%.
اوكي، راه مزيان
مزيان دابا شويه.
اوكي، دونك انت كتهضر الدارجه، فرونسي، لونجلي والالمانيه كذلك.
دابا ملي تمشيو للصحراء، كاينين الناس اللي تيدويو ماشي ما تعرفوش يدويو بالدارجه، تيدويو بالامازيغ. ودابا انا نحاول جيساي دابخوند شويه الامازيغ.
اوكي.
دابا تي لور دي انا تنخدم على العلامات ديال الديناصورات و سا، يكومبرين با، دونك يفو كو تي لور ديزون امازيغ اي سا هي ابخي يكومبرين. دونك سي
وكيفاش تشرح لشي واحد انك كتخدم على الديناصورات بالتمازيغ؟ شنو كتقول لهم؟ اعظام كبار ولا لايك
الناس كي فيف هاد لا ريجيون تعرفوا هادشي لي فوسيل.
اوكي.
صاف هادشي سي دي شوز تري انسيان. ولكن انا جو لور اكسبليك فوالا سيت اندروا سيتي واحد الواد كبير وكانوا فيه الديناصورات ولي كروكوديل وهادشي. ولكن ils comprennent le concept des fossiles. تعرفوا زعما سي كيك شوز دانسيان.
اوكي زوينات. غادي نهضروا عليها من بعد، على القضيه ديال ان الثقافه اللوكال، ان الناس لوكالمون يكونوا كيفهموا الاهميه ديال حاجات بحال هكا ديال المستحدثات من الناحيه ديال المحافظه عليها والحمايه ديال بو بريزيرفي هاد لي فوسيل من لا ديستركسيون ايتترا. اون فا بارلي دو تو سا. دونك انت تزاديتي في المانيا ياك، الوالد ديالك مغربي والوالده المانيه. Okay, so maybe you can switch to English if we're
Sure, we'll
gonna
back and
talk
forth.
about science. Yeah, that's
Like
fine.
all
You can
Yeah,
talk. You know.
I have this very international research team.
Oh yeah.
لما عندي des gens من l'Angleterre, l'Allemagne, les États-Unis, l'Italie. On a bien sûr les collègues sur place marocains. Donc c'est un grand mélange. Tu entends toutes les langues. C'est une équipe. Et la science ne connaît pas de frontières. Donc c'est-à-dire que we're working across cultures and borders, and it's a great team.
Absolutely. But I must say that the literature and the content available in English for science is way more than, at least what I've seen, is way more than any other language.
Yes, that's actually a very important point. I mean, there was a point in time, or a period in time, when much of the scientific literature was in German, for example, right? But if you look at publications today, it's overwhelmingly written in English, right? And so that's actually one of the problems I have with much of science education in Morocco, because much of it still happens in French for historical reasons. These young scientists are really poorly prepared to enter the world of science, because everything is written in English, all the publications, all the conferences. And so I think it's important to recognize that, a good grasp of English writing and speaking is really important in science today.
That's right. And not just scientific research, but I would even say that even like basic scientific literacy or basic, high school material. I know many young people who have access to this whole world of English speaking scientific course or scientific literacy content, and they excel because they get a diverse way of people explaining the science in very different way, very and new ways that are not taught in school, or not even in French speaking content creators. So there is this whole diversity and richness in the English speaking world, and that's
I think it's a big issue in science education in some parts of the world. I think this is something that really has to be addressed in Morocco and some other mostly African countries with historical links to France.
Yeah, English basically frees you up. I mean, I can tell you from my personal experience, when I got out of Morocco, and I started after the internet started being big and YouTube started being big, I discovered so many topics completely from scratch. Topics that I have studied at school, even philosophy, for example. I used to learn by heart all these questions, and maybe recite the answers in the exam and get a good grade. But I didn't grasp the actual philosophical ideas until I rediscovered them through this new world.
Yeah, well, that's another kind of legacy of the French system. I went to a French school in Berlin, in Germany, Lycée Français, and so many of the classes were in French, but we also had German, just like you would in a German high school. But there's certainly a really big difference, and I could tell, if you're in a place like Berlin, you can kind of compare notes, as it were, with your friends and so on. And the French system is very much about learning things by heart. There's not much discussion, right? It's very much top down, right? And that's quite different from some other educational systems. But I agree with your point that it really opens up many doors. I think in Morocco, you often have this very narrow view of what you can do. So already you're limited by what your baccalaureate is, right? You say like, okay, I did this one or that one, and then you go like, okay, I can go to an engineering school in Morocco or in France, but it's kind of the same thing, right? It's like this system of grandes écoles, and you really buy into this idea that this is great, right? And then you realize later on that nobody in the world even knows what the Grande École is. You know, so you were in a big school. That's nice. Was it a big building? You know, and of course, you know, you realize there's much more to the world. You know, and you realize when you know, I don't know. I mean, talking about engineering, for example, you know, like many parts of the world, if people want to hire an engineering company, they're like, oh yeah, we'll hire this German engineering company. It's like, you know, am I going to buy the Mercedes or the Renault? You know, it's like, and you realize there's much more to the world than just this kind of Franco-Moroccan universe, right? The bubble, right? And so I think it really does open up a whole new world. And it's sometimes painful for me to see Moroccan students, for example, attending international conferences, and they can't communicate. You know, they're supposed to present their research and they're really struggling, you know, because everything they learned, their whole upbringing was in this French bubble. And then all of a sudden they're expected to converse about scientific topics in English, right? So I think it's really important to make sure that the science education and education in general reflects the world out there. You know, there's more to the world than just, you know, this one route. And I think you sometimes hear stories of Moroccans that kind of broke out of this and ended up all over the world, you know. And I think it's a growing, you know, community. And I think these people all advocate for this change. And we'll see if that happens. I mean, it's tricky. It's complicated.
Yeah, let me tell you, because you spoke about community, I did a poll in my Facebook page related to this interview. So I asked people, you know, I have a guest, he's fluent in French and in English, but his Arabic is probably, we cannot have a scientific conversation with the Arabic. So I would like to, so what do you think? Should we do it in English or in French? And to my surprise, it was 2/3 saying English and 1/3 saying French. And then on Instagram, I added another thing. I said, let's assume we put Arabic subtitles to this interview. Would you still go for the French or the English? And then it became 83% saying English with the Arabic subtitle versus 15% saying French. So the community is growing. I was surprised actually by this.
Yeah, I think that's interesting. I think that suggests that young people know, you know, what we were just talking about, you know, and so they're pushing for this in you know, different ways.
Yeah, at the end of the day, the quality of the content takes over because, you know, when you look at documentaries that the BBC or, you know, Planet Earth for animal lovers, there are big productions that have this, you know, deep, both excellent scientific content and very good production value. And this kind of thing exists mostly, I would say, in English.
Yeah,
so,
I think that's certainly.
So many people really fall in love with science through the English content. Maybe that's while the French is like more of an education thing with a teacher that writes on the blackboard and you have to learn by heart and so on. So
yeah.
Anyway, so maybe that takes us back to you and to your passion for science and paleontology. How did it start? Where are the roots? How did it start?
Well, I was born in what is arguably the coolest city in the world, certainly for young people, in Berlin, in Germany, which is it's a great place. It's not at all a typical German city. It's a little crazy. But it's a wonderful place because for different reasons. I mean, I was really interested from a very early age in nature and science and animals, and particularly extinct animals. You know, I had a book on extinct life, including dinosaurs, and I was just hooked. I was blown away. But Berlin was also the kind of place where you could grow this passion, right? So there are lots of museums, an amazing diversity of museums, including a world-class natural history museum, but also many different other types of museums, you know, with archaeological treasures and, you know, all kinds of things. And so it was a place where you could feed your curiosity, right? It was also a place with lots of outdoor places. Many people don't realize this, but Berlin is about half of the city is forests and lakes. So you have a lot of green spaces. You can go out into nature and you have this connection with, you know, the natural world. And I guess from a, different angle, it was also a great place to grow up in, because you can be anything you like in Berlin, right? Doesn't matter, what you believe, what you wear, what color your hair is, So, and that was one of the reasons why in Germany, many people that didn't really fit in elsewhere, came to Berlin, So it was a really great place to grow up in. And I think I've lived in so many other places now, and it's only when you've been away for a long time that you realize, that, how special a place it was. And so that's where I grew up. And, I was lucky that I had access to all these cultural resources, and we'll talk about that later maybe, about the importance of having access to museums and exhibits and zoos, aquariums, I also was lucky in the sense that, my mother is a veterinarian, so she had a deep-seated interest in animals too. And, so it wasn't that anyone was kind of trying to kill my interest in paleontology and say, oh no, you've got to be a lawyer or an engineer or a doctor or, kind of the pharmacien, It was like, sure, and so that's really how it all began. It was, and it's a journey that has taken me all over the world. I ended up getting my undergraduate degree in the UK, in Bristol, which was a great place to study paleontology, biology, geology, and so on. I got my PhD in Ireland, which is kind of interesting. It's a place with no dinosaur fossils, but that's where, I got my PhD in the anatomy department there. And then this was followed by a postdoc at the University of Chicago in the United States. So that's when that jump over the pond happened. Now I'm still in the Midwest. And I am a paleontologist, but I think many listeners in Morocco will be surprised to hear that my teaching is in anatomy and evolution. So I don't teach, something that would, I think many people in Morocco think that paleontologists kind of dig up things and they're kind of interested in rocks. And but here in the US, many of us actually teach anatomy. So that's what I do here. And that's what I do in this lab. We do all kinds of things here. We dissect different kinds of animals, including humans. We look at bones and muscles, you name it. And we also look at what I would describe as the greatest story out there, the history of life on Earth. So I also teach evolution, this incredible journey through time.
So it all fits together, right? Because if you're talking evolution, then you're talking changes in the morphology of creatures. And then to understand deeply this change, then you need to be an expert, or at least you need, in the pool of expertise, you need to have people who are experts about anatomy of animals and so on,
yeah.
Right?
Well, there are a few unique things you can bring to anatomy teaching as a paleontologist. So if you learn human anatomy, maybe at the university in Rabat or some other place, it's essentially going to be, again, very much learning things by heart. And you know where the muscles are and what they're called. And, that's an important part of learning anatomy. But you're not really going to understand why our body is put together the way it is. And that's, I think, a really important thing to understand. And so what paleontologists bring to this discipline is a big picture perspective. Why do our teeth look the way they do? Why do we have back pain? What are the evolutionary consequences of walking upright? How does that affect our body today? And so, when you look at any piece of the human body, and I've done that, many times, dissecting human bodies and training the next generation of health professionals here in Michigan. And say you look, let me just grab one thing here. This is just a model. Say you look at the human head, right? And all these nerves and muscles all the soft tissues, all of these different components can be traced back over hundreds of millions of years. In fact, many of them are already present in fish, very ancient fish. And so the basic wiring is already there. And so piecing that together is pretty amazing, right? It is really amazing to understand that all of these anatomical features we have can be traced back over such incredible distances in time. And of course, students also learn why, say, my hand looks quite similar to this hand here. This is the hand of a manatee. This is a water-dwelling mammal. And you see the same kind of basic patterning as radius and ulna, the hand bones. You can see how they're modified in different organisms. This here's a different one. This is a dolphin flipper. You can see the fingers are modified in different ways again. And so by getting this comparative perspective of anatomy, they become better anatomists, right? They really understand why our body works the way it does. And
sorry to interrupt, just a small parenthesis or an example of what you're saying. I was talking to a medical student, and I brought up something very fascinating. I heard in a lecture of Professor Robert Sapolsky. I don't know if you know him, he's in Stanford. Right. And he gave this example. He said, the way we close our hands is very fascinating, because apparently there is first one signal that goes and tells the hand to close entirely, and then if you want to close only one finger, then it's a two-step process. First there's a main signal that says close hand, and then there's another signal that says no, put back the other fingers. And the reason for that is that it was shaped by evolution through the first layer which we inherited from ancient apes and monkeys that said that only used the hands mainly to grab, in the branches and so on, but the dexterity and the ability to move fingers in a very sophisticated way came way later in the evolutionary process. And the medical student had no idea what I'm talking about. It was like, yeah, there is this signal thing, but the big picture was missing.
Well, there's a saying, which I'm sure you know, and it goes like this: nothing in biology makes sense except in the light of evolution. And you can apply that to anatomy. Nothing in anatomy makes sense except in the light of evolution. And I have, I don't know if I have the hands here. I actually have hands of different ancient hominids. So, that's one of the things we do. We track things. So I don't have the real bodies here, but, we look at the entire skeletal system. We look at all the muscles and nerves and pathways. And many of the pathways of nerves, for example, seem really bizarre, really, really strange. And then you realize that the basic wiring made sense in a fish, but then, the bodies were significantly modified. And so all of a sudden the wiring becomes really awkward, right? There's a famous example. There's something called the recurrent laryngeal nerve, which in a giraffe does this huge loop. It's really only supposed to cover a distance about this long, but it goes all the way down the neck and up the neck again. And
it goes around the heart, I think.
Exactly. Yeah, it loops around an arch. And so in ancient fish, this made a lot of sense. Fish don't really have a neck. But then in humans already, it's kind of an odd loop. But then in a giraffe, it's just absurd, right? And so all of these things, you can learn them by heart. But I think it makes you a much better anatomist when you actually understand the deep evolutionary origins. And also if you understand just how malleable bodies are, how they change over time, and many people are familiar with dwarfism in other animals, for example, right? One of the things we look at is dwarfism in our own family tree, right? This is a dwarf human, Homo floresiensis. And they almost certainly became so small because they were on this, living on this island of Flores.
Okay, wait. So Nizar, the first question they ask when they see a human fossil, evolution fossils, is weren't these just sick people? Actual human dwarves or people who had some sort of disease? How do you answer that?
Of course, one of the things we know is, and we have a wide range of amazing fossils, considering how much has to go right for an organism to turn into a fossil. It's amazing how many fossils we actually do have. And this here is one cabinet that has some of these characters. Here are some of them. And the thing is, this is a Neanderthal skull here. This is Lucy, Australopithecus afarensis. I mean, you can put together, you can flesh out a big evolutionary tree. One of the things we know, of course, is that all these skulls are found at certain points in time. So these are not somewhat, diseased human beings. Some of these organisms lived millions of years ago, right? And they show this incredible mosaic of features in some cases. Some of them are very human-like, others are not. What's also important to remember is that we are not the only humans. We are the only ones left today. But we know, for example, that in many parts of the world, especially in cold climates, Neanderthals were making a living. And those are humans, right? This is the same genus, Homo. These are called Homo neanderthalensis. And so when you look at the human tree and you look at the distribution in time and space and how it matches, movements of different species across the globe, then it's very apparent that we're not looking at a bunch of diseased humans.
And you have clusters of these remains, so you would have tens or hundreds. Maybe you tell me the number of Homo erectus, for example, or Neanderthal. There are many of them. So
we see these very gradual changes over time. So I think the picture we're seeing now of human evolution is one that is not this kind of old-fashioned ladder-like pattern where you end up with Homo sapiens, the pinnacle of everything. What you see is this very complex branching pattern. And I think one thing that this shows us is not only that we're not as special as we like to think, it certainly teaches us humility in some ways. Some of the Neanderthal skulls I have a bigger brain than most Homo sapien skulls, right? And so we always try to maintain this special status. And so we might say, brain size is the most important thing. And then we find out that some of these guys have bigger brains. And we say, well, brain size is not really that important. It's just really all about how the brain is wired. And, so we always try to make up new rules, right? Or we say only humans use tools. And then we find out that chimpanzees use tools, right? This is the skull of a chimpanzee here. And we say, well, actually tool use it's overrated. So it's interesting how this really forces us to understand that we are part of this big epic story of evolution on planet Earth. And I think it also raises some really interesting ethical questions. We're now in a time where we're always, we're wondering about, how we can improve our societies, how we can live together in a world without, racism and all of the other nasty aspects of human behavior. But I think I sometimes ask my students, what do you think would happen if Neanderthals were still around today? How do you think they would be treated, right? And most of them say, well, probably not very well, right? I mean, we don't have a good track record, right? And another really interesting aspect is if you consider that not that long ago, several different types of humans coexisted on planet Earth. Many of the concepts we take for granted, like human rights and, all those things that only apply to us and no other animal, become they're kind of on shaky ground, right?
Yeah, that's right.
Uniqueness and, humans have this attribute and that and the soul, it all suddenly crumbles because it's really just through accidents of Earth history that we happen to be the only species of humans that is still around. So I think those are really important questions and with lots of fundamental implications. And I think rather than trying to desperately discredit evolutionary biology as is happening in some parts of the world, we should just be amazed at all the things we found out. And I think it's really magical when you realize that, you and I and every other human being on this planet is related to all the other living things on this planet. This relatedness, I think, is really special. We're all in this together. And we know this on many different levels. We know how everything is interconnected, from organisms, ecosystems, and to realize that we're not this special thing that's kind of set apart from everything else, but that we are, you and I are the result of this incredible unbroken chain of survivors that goes back, that snakes back in time over hundreds of millions of years, is incredible. It's an amazing story, right? And I think it has some really big implications. And yes, it does teach us some humility, in the same way that astronomy teaches us humility. It shows us how small we are in space. Whether we like it or not, we are very small in space. And evolutionary biology and paleontology shows us how small we are in time.
Yeah, absolutely. And the more you learn about it, the bigger it seems. Just the example you brought of the human species as being part of a bigger tree and a bigger maybe we can call it an earth organism. It's like a huge organism that we're just a small branch in a thing which is life on Earth. And when you look at it, even a human body is actually a sort of colony that has many species living together. We're like an ecosystem moving. We have bacteria in our guts, in our mouth, so we are interconnected in so many different ways. Not only the unbroken chain of descendants, but also in the whole ecosystem in which we live. We are completely interconnected. Maybe if the bees die out and get extinct, maybe we will directly be impacted because of this whole connectedness.
Well, yeah, and I think that's one of the things we have to keep in mind, when we're pondering our own survival and how long we're going to be around. As a paleontologist, I can tell you there's no exception to this rule. All species go extinct one day, right? Humans are not going to be an exception. And so the question is, how do we make it last as long as we can? And how can we make sure that future generations inherit a planet that is, more or less viable? And I think, yes, one of the most important things we have to realize is that, we are very much dependent on the rest of planet Earth. We're not something set apart, the planet is not there for us to plunder and pillage. I think those are important concepts, So I think this superiority complex that humans often have is really a big obstacle for our own survival.
And this perspective that you took me into it now, I'm in it now, and I hopefully the audience as well. You keep finding it again and again and again in the stories that science tells us, especially science in the last 200 years. And you mentioned deep time, and one way that deep time teaches us is how, when you think of this mind-boggling 4 billion years, and the waves and waves and waves of organisms that came and disappeared and came and disappeared, and these mass extinctions that happened, then you completely have a new outlook on the way life is as you see it. And maybe some people are saying that humans are starting a sixth extinction. So we have become so powerful that in an arrogant way, as you mentioned the word earlier, that the impact we're having on the planet is as bad as some of the major impacts that either asteroid impacts or volcanoes or major events that happen in geology. So how do you look at it?
Yeah, I think there are really two interesting sides to this. On the one hand, you're absolutely right. And I think that's one of the reasons why paleontology is so important. And again, some people in Morocco might wonder, so what exactly do you do as a paleontologist? What is your big contribution to society? And I can say, well, on a practical level here, for example, I'm training the next generation of, medical professionals, right? If you come to a hospital here, people will have learned their anatomy in my lab here, right? But then on a different level, I think paleontologists piece together this incredible story, the history of life on Earth. And you're absolutely right. 99.9% of all the organisms and all the ecosystems that have ever existed are extinct, right? So that's really a a big revelation for some people. And then you realize that this tiny little slice of time that we call the present, everything we care about, you know, our societies and, you know, the
coronavirus
and all of that is a tiny little slice of time.
The coronavirus, you know.
Yeah, exactly. But in the grand scheme of things, it's really pretty small. And so, you know, there's a certain irony to this. Sometimes people go like, well, you're a paleontologist. That's a very, very specialized job, right? And you kind of think, well, no, not really. Being a financial advisor in this particular point of time, in this particular economic system, that's very specialized. I look at the history of life on Earth, right? So what this big, deep time perspective shows us is, how our planet responds to global scale changes. And so all the things we're worried about now, biodiversity loss, changes in climate, and so on, those things have happened in the past, on a scale that we cannot even begin to imagine. So if we really want to understand how ecosystems recover from such major events in the long term, we have to look back in time. We can use computer models to predict the future, but the only way to really understand how these things play out is to travel back in time. Massive sea level rises happened many times in the past, and so it's a really important perspective because it really informs our actions in the future. So that's this one aspect. I told you there are two sides to this. The other one is, so yes, we are very powerful. We are causing a mass extinction right now. I think that there are many different ways to look at it, but I think, yes, we are. And certainly in some ways, we are causing a massive mass extinction right now. And this one is not due to a meteorite or a volcano. It's us, humans. But then there's another side to this. Yes, we are powerful, but we also kind of overestimate our power. Because as you said early on, at the end of the day, we're shooting ourselves in the foot, right? Because if we deplete our oceans, destroy our rainforests, do all of these things, we are the ones that are going to go extinct. We will take many other species with us. We'll cause a lot of damage. There will be no more, lions and rhinos and elephants. But some animals are going to survive. Some organisms are going to survive. Our planet is going to recover. We're not that powerful. We cannot completely destroy planet Earth. And so planet Earth is going to recover. Those things can take millions of years, this process of recovery. But the planet will recover. But we're not going to be around when it does, right? And so I think we also have to recognize that, yes, we have this power to destroy an awful lot of things. But at the end of the day, the planet is going to recover at some point. Yeah. But, if we don't play it smart, we'll be some of these, large vertebrate animals that go extinct.
That's right. So the Earth will outlast us for sure.
Yes.
So the only...
Sorry,
yeah.
Go ahead.
No, sorry.
No, I was just going to say that's one of the reasons why I'm always a little careful when people get too enthusiastic about escaping to Mars. It's a big thing today. It's like, well, we'll just trash our planet and move on to the next one. Like, locusts or something, like a swarm of
yeah.
But it's a pretty nasty place. I'm all for space exploration, but let's face it, we only have this one home, and it's an amazing place, and it's a place of wonder and beauty, and even the most hostile place on Earth, and I can think of a few. And the Sahara is a pretty hostile place, right? Mm-hmm. And yet the Sahara is paradise compared to Mars, right?
Yeah.
So I think, so I think we have to accept that we need to figure out a way to make this work, and we can't just run away.
Yeah, the only option we have is to sort it out. There is no other option. If we screw up, then I think c'est dommage, like we say in French, that it would be a pity.
That would be a bit of an understatement. C'est dommage.
Yeah. Like we can, yeah. No, what the most fascinating thing, at least for me, probably you share the same perspective, is that we came to this point in the history of life on Earth where we have this special thing, which is a brain that can grasp these things and that can have these reflections and think of deep time and some people just cannot understand how special that this thing is, and they
well, it's
du gaspillage.
it is interesting because on the one hand we are very smart, and le grand cerveau and all these amazing attributes. ولكن en même temps, on a une tendance à juste voir le futur très proche. We have no real long-term thinking or long-term planning, which is not a great sign of intelligence, if you ask me. So you know what I mean? Like people say, oh, we have to continue over-exploiting our oceans because, you know, the fisheries industry depends on it. But then if 10 years down the road, the fisheries economy completely collapses, that's not a good solution either, right? But we're really bad. And politicians, for various reasons, also because they're only elected for a few years in many cases, cannot really, you know, they don't like to do this long-term planning, right? And kind of kick the can down the road. You know, they try to say, well, we'll figure this out at some later point. But I think we are very smart, but it's kind of frustrating because we understand what's happening. We understand it's bad. We understand we're really poisoning our environments in many places, and yet we seem to be unable to stop it. You know what I mean? It's kind of a really, and so when you really ask deep down how intelligent or smart are humans, it's actually not that easy to answer. And certainly in evolutionary terms, when we ask about success, I don't think that humans are going to go down as particularly successful, because in terms of, in some aspects, yes, you know, we've kind of conquered the globe, we're everywhere, we're very abundant, but, you know, if we don't really last very long, you know, many modest, humble little insects will actually be more successful, evolutionary speaking, because they've been around for much longer, right? So it's, it's something that we really need to think about more. And this, you know, is one of the reasons why scientific literacy and education is so important. We need more people to really think about these big questions. I think it's, you know, our survival depends on it.
Yeah, and the only, well, just to comment, a small comment on what you just said, at least what I see, the special thing I see about Homo sapiens is probably Neanderthal would have been similar, but now it's extinct, so there's no reason to talk about that you know, eventuality. But the special thing about Homo sapiens is the opportunity, if you know what I mean. We could, if we behave properly, we could do something very beautiful in the history, not only of planet Earth, or maybe the history of the universe. Maybe we are the only planet that has an aware or a conscious civilization. So, and we have this opportunity, we have this brain that can grasp things, and you know, not all of us have this long-term planning, as you say, but some of us have, you know, people who have who these reflections, and it's an opportunity that if we behave really, and as you said, the importance of scientific literacy and so on, some people say we should take, I talked to astronauts in this show, and some people say if you take the world leaders and you take them to the International Space Station and you have them look at planet Earth from outside, maybe they will come back completely different, because they would have this perspective, this mind-boggling big picture that science teaches us. So maybe the same thing with paleontology and with the history of with this place of humans in planet Earth. If someone has a time machine or some way of visualizing the history of planet Earth to these politicians, maybe they can grasp what you're saying, but most of them don't.
Yeah. I'm just going to say I don't know if it's going to work with all politicians. That's all.
I know of at least one with which it won't work.
You can try and read between the lines. But I think that's certainly true. But I also think there are some parts of our behavior that are pretty deeply ingrained and they're a little problematic. And this is something, the science on this is not settled, but I think there, you know, we have these two sides, right? There's a pretty dark side to humans, and we see this in some other animals, you know. Jane Goodall famously described this in chimpanzees. They can also have, the different chimpanzee groups go to war with each other, and which, by the way, is very different from what we see in bonobos, for example, which are, they're very closely related and have completely different social behavior. In humans, I think one of the reasons we were and still are successful is I think that we have this ruthless, brutal streak to a certain extent, right? And that may have played a role. That might be the reason why we are the only species of Homo that's still around, right? And so this kind of, and you see this, when you look at the arrival of humans in different parts of the world, you see these big extinction events. They kind of take over and become very dominant, and it's pretty brutal, see the extinction of other large mammals. So I think some of the problematic qualities we have, ironically, were also key to our success, right? Mm-hmm. But now that our impact is so much bigger because there's so many of us, and we have massive industry and all kinds of other things, it's really becoming very problematic. And so sometimes I wonder, there are also some underlying, deeply rooted aspects of our behavior that are maybe quite difficult to overcome, right? And so I think we're always in this struggle, using our brains in the wise and good way. But we also, I think, one important step is to acknowledge that we also have this dark side. We have to be aware of those things that make us successful to a certain extent, but in the long term, again, it might actually spell our end.
Yeah, and humans as an organism, it's crazy how this way of thinking that you're talking about comes and goes in waves. So like people during the Cold War, everyone was scared. Maybe there's one person who has the button, that push the button, and everyone is dead, and everyone was talking about that. And then now everyone forgot about that. People there's a rise of ideologies that can remind some people of Nazi ideology. Everyone is like, there's a short-term memory kind of to mankind. It's very scary.
Human history is littered with all kinds of warfare and genocide, and and you always assume that we kind of learn from the past. But I'm not quite sure we're really that good at it.
It's crazy. Listen, well, now that we know a little bit more about paleontology, how it fits the big and the way bigger picture of where all this, talk to us a little bit about your specific work in Morocco, in the Kemkem region. How did it start? How did your interest in the Kemkem region start, and what did you discover there?
Well, when we look at people sometimes ask me, well, why don't you do a lot of fieldwork in, Wyoming or Montana here in the United States, which are great places to find fossils, or China, where amazing fossils have been found in recent years. Why Africa, right? And that's kind of part of the key here in my answer. When you look at this history of life on Earth that I described earlier on, we have a certain narrative, right, of how it played out. And there are some big chapters, and the Mesozoic, the age of dinosaurs, is one of them, a really important one, because it saw the rise of mammals, for example, and birds, and the very dominant dinosaurs, and major changes in the position of continents. Very important chapter.
How many years ago? Sorry, approximately. How many?
Well, it came to an end about 65, 66 million years ago, when the big meteorite impacted our planet and spelled the end of the dinosaurs. But it played out over 180 million years. So it's a very big chunk of time.
A million years.
Yes. And when we look at these narratives, they are actually quite heavily biased. So much of what we know about the history of life on Earth is based on fossils and museums and universities and scientists located in North America and Europe. So it is in some ways a very Western perspective. We now have more important, we now have some important contributions from places like South America and China, which I mentioned earlier on. But one place our planet's second largest landmass, Africa, is severely lagging behind, right? And so for me, there was always an interest in filling some major gaps in our understanding. And so because we know so little about Africa's age of dinosaurs, there was a really good place to start. But there was another reason, and that's kind of a really interesting background story to my work. I was inspired by a pioneering German paleontologist, Ernst Stromer, from Bavaria. And he had decided to scour the shifting sands of the Sahara Desert in search of fossils. He was a real pioneer, very accomplished scientist. And he uncovered incredible things in North Africa. He did a lot of his work in Egypt. And one of the things he found was a bizarre fossil assemblage in a place called the Bahariya Formation. And what he found was a treasure trove of fossils, dinosaurs and crocodile-like hunters, lots of different types of fish. He also found a really enigmatic giant predator called Spinosaurus, a really, really strange dinosaur. He had described a few bones of this animal. And so he had assembled this pretty important collection of Saharan, African dinosaurs. Unfortunately, all his great discoveries were lost to war. Stromer was he was an outspoken critic of the Nazi dictatorship, but unfortunately, he was not successful in having his fossils, which were on display in Munich, in Bavaria, moved to a safe location. The director of the museum at the time was an ardent Nazi supporter, and he refused to have the fossils moved to a safe location. And so in 1944, a Royal Air Force bombing raid destroyed the museum. Of course, many other parts of the old city of Munich were also destroyed. And anyway, so he lost almost all of his incredible finds. And so this story of loss and, Saharan dinosaurs really caught my attention. And so I started making plans when I was still an undergraduate student to go to North Africa to kind of resurrect Stromer's world of Saharan dinosaurs. And so I looked at different options. Egypt was an option, Tunisia, Algeria. When I looked at the map, I saw that Morocco had geological outcrops of roughly the same age as the ones in Egypt, except that in Morocco there was even more outcrop. It's they stretch for over 250 kilometers along the Moroccan-Algerian border, and I also knew that there were logistical difficulties in going to places like Algeria and so on. Still on my list of things to do, but at the time, I had to put together a project for my PhD thesis, and so I decided to visit this place known as the Kem region in Morocco. And I wanted to learn everything I could about this place and the animals that lived there. And so that's how that began. And over the last few years, we collected thousands and thousands of fossils. And we pieced together a really incredible lost world, an ancient ecosystem. And this really famous predatory dinosaur, Stromer described, Spinosaurus, we found a new skeleton. It's the only one in existence in the world. So after the destruction of all the other Spinosaurus bones in World War II, nobody had found a new skeleton for decades, and now we have a new skeleton of Spinosaurus. So we really put, the Sahara's dinosaurs back on the map. And, for Morocco, I think this was also a big win, because, these discoveries made headlines all around the world. We established a research collection in Casablanca in Morocco. And some of these fossils are amongst the rarest, most important fossils from this slice of time in the world. in particular the skeleton of Spinosaurus. And so it's been a pretty interesting journey, but that's what took me to Morocco.
Okay, well, so many people, when they picture the image of a paleontologist discovering a fossil, they think they say they use the word stumble across, or they like as if you're just hanging around in the desert and then there's the Spinosaurus over there. So how does field work? How I'm sure there's a lot of planning, and you don't just stumble upon a fossil.
Well, I guess yes and no.
Okay.
We don't just go to a random place and start digging, right? Right. We look at geological maps of, for example, the Sahara, and so we look at the distribution of different types of rocks of different age. So in my case, we look for rocks that are approximately 100 million years old. And then we go to these places and we start prospecting. So there's a lot of walking involved, walking in 45 degrees temperatures in the Sahara, and with snakes and scorpions as your companion. So it's not always the easiest thing to do. In fact, it really pushes you to the limit. And then you look for clues on the ground. And in many cases, what we find in this part of the world is we find isolated bits and pieces. So I'll show you one example. This one is actually from Egypt, but we find the same kinds of things in Morocco. This is a Spinosaurus tooth, right?
Wow.
So you find isolated teeth, and they're actually sufficiently common to actually make it into the big market in Moroccan fossils. So you can actually, some people buy Moroccan dinosaur teeth on eBay or whatever on the internet. But of course, what we want to find is associated skeletons. And that's very, very, very difficult. So although I should rephrase that. We do also, we collect everything, including all these isolated bits and pieces, because even these isolated bits and pieces tell us some very important things about the ecosystem that existed in this place. So you find a little piece of turtle shell and fish fossils and teeth of different kinds of dinosaurs. So you kind of know what types of animals lived in this place. You can try to reconstruct the environment. So all of these pieces are important. But if we really want to understand the biology of some of these animals, we need to have an associated skeleton. And that's a very difficult process, but we've been lucky. We found some pretty amazing things over the years. We found some remains of a very, very big plant-eating dinosaur, an animal that would have weighed as much as an entire herd of elephants, an absolutely massive animal.
Wow.
As well as the skeleton of Spinosaurus. We found remains of giant flying reptiles. So really amazing fossils that have captured the imagination of people all around the world. The Spinosaurus discovery in particular really started a flood of public interest like we've never seen before in paleontology. So in many ways, it was actually, these discoveries were great for paleontology, but I think they can also serve as starting points for new, museum projects in Morocco. I'm hoping that people in Morocco are now more aware of the incredible ancient heritage that the country has.
We will talk a lot about this in the next segment, maybe. But tell me more about the science of fossils. You said when you walk around these regions, you find a lot of teeth. I think because teeth are the most resilient, maybe parts of the body that survives. So most of the fossils are not. Why? So one naive question that someone would ask is, if there has been these billions of creatures that have lived on this planet, and you said 99.9% of all the species that have ever lived are extinct, why don't we just find animal remains all over the place? Why do you have to go and under 45 degrees in the Sahara to look for them?
Well, there are different reasons. One is that you need to find the right types of rocks exposed at the surface, right? And so in many places, it's really hard to find fossils because there are buildings and there are, forests and there's grass and, so that's one reason why we like the Sahara. There's nothing else there. It's just, rock is exposed. We're not going to find a big, grassy, area in the Sahara. The other thing is that it's not easy to become a fossil. People think it's easy. The first step, of course, is you have to die. And then the second step is you have to be lucky enough to die in a place where you will not be immediately, eaten by scavengers or, small, tiny organisms that will decompose your body. You also want to be in a place where you're rapidly buried. And then, of course, you want to make sure that over the next few millions of years, you're not, dissolved or crunched or, so many things can happen as, geological processes occur. And then, of course, you have to be pushed to the surface, and then you have to be a lucky fossil that's actually spotted by a scientist or just a member of the public, And so the vast majority of organisms do not become fossils, right? So that's an important thing to remember. And you're right, some fossils are more common than others, and you're right, teeth are pretty durable. But one of the things that apply to the dinosaur teeth here, for example, one of the reasons why they're relatively abundant is that unlike you and me, dinosaurs would not have needed a dentist. These predatory dinosaurs, for example, they would shed a tooth or a tooth would break off and a new one would grow back. Really cool.
Wow.
So dentists would
it happens many times during the cycle, life cycle?
Dinosaurs will shed many teeth over a lifetime. And they just grow a new one. And
so maybe if you're lucky, you could find two teeth belonging to the same individual. That would be crazy.
Well, sometimes you find a jaw.
Something like in the same spot.
Well, sometimes you find a jaw and you actually see one tooth and then you see the next one that's already kind of pushing to take the position. And so you see that. It's different from what we see in sharks, for example. And I think many people know this, but I think I have a shark jaw accessible right here. So in sharks, what happens is, there we go. These are shark jaws. So this is a shark jaw, and you can see the teeth. This is like in a river. It's like a conveyor belt of teeth. Here's another one. And you can just see like all the teeth there waiting. And so they're constantly being pushed forward. So it's, there are different ways to replace your teeth. That's actually one of the things that I always try to teach my future dentists. Many of my students are interested in becoming dentists. And it turns out they know very little about the evolution of teeth. So I make sure they really understand that there are more ways to build a dentition than what they would see in human patients. But anyway, I explained to them why we have wisdom teeth and all kinds of other things. So anyway, yes, fossils are more abundant.
Sorry. So the wisdom, I know it's another parenthesis, but the wisdom teeth is because of the herbivore ancestry or the.
Yeah, it's something that's still kind of a topic of research, but there are shifts in our feeding, and there was also a time when, again, even humans didn't have dentists, and having potentially an extra tooth would actually come in handy. And also, there's certain things in our bodies that are not incredibly detrimental. So, they kind of still hang around. But the short answer is that, we just reduced the space available for our dentition. If you actually look at the short snout and you just look, the amount of space for teeth, they just suddenly become really, crammed in there. And again, I think this is really important. If you're a dentist, I think you should know how we got to this type of dentition and why, we don't replace our teeth all the time. There are certain, you can actually trace back the origin of a differentiated dentition. So in our lineage, way back to creatures we call mammal-like reptiles, which is a bit of a misnomer, but that's what they're commonly called. And in some of these creatures, like for example gorgonopsids, which are fearsome predators, you see a differentiation. The front teeth are different from the big stabbing teeth, and so it's like you start to see this pattern of differentiation. And again, this is a very ancient evolutionary trait to have this differentiated dentition. And then you look at things like our very precise occlusion, right, of our teeth, which again, that wouldn't work if we were always replacing our teeth, because you need to have this very, very precise occlusion, right? So anyway, again, I'm kind of going back to our evolutionary theme, but yeah, teeth are really interesting.
Definitely.
And so some fossils are more common than others for reasons like in this example.
Yeah, so how did you find the Spinosaur? What happened? I know there's a mustache man that I'd like you to tell us about.
Well, it is a crazy story, but it's like something straight out of a Hollywood movie, because we're finding bits and pieces of Spinosaurus, mostly isolated teeth and so on. And it was only in April 2008 that things really changed, because on the way back from our field work, we briefly stopped in a small oasis town, and we came across a local man, and he had a bunch of fossils in a cardboard box. He was also working with another collaborator, but they basically had this cardboard box, and the man showed us the fossils, and they looked very strange. They all looked like they came from the same place. They belonged to the same animal, probably. You could see there were bones in there, but everything was covered in sand and sediment. And I just had this gut feeling that maybe this is something really important. There was one bone in particular that really caught my eye, and there was a blade-shaped bone in the box. And I just couldn't quite figure out what it was. I thought maybe it's a piece of a rib of a very, very large dinosaur. And I thought, but maybe it's part of a blade-shaped spine of Spinosaurus. Spinosaurus has these big, tall spines on its back. And we know it had these big spines because Stromer described these spines, the German paleontologist I mentioned earlier. And so I thought maybe this is something important. And so we made sure that these bones came to the paleontology research collection at the University of Casablanca. And I thought one day I'm going to figure out what this is, But it was always in the back of my mind. And at around that time, I was also visiting museum collections all around the world to look at fossils from the Kem region and other parts of Africa. And on one of those trips, I visited the Natural History Museum in Milan, in Italy. And my Italian colleagues showed me their African fossils. But I was also there because they had told me that they have a partial skeleton of a dinosaur sitting in their collections. Not on display, but in the museum research collections. And they said that this skeleton was uncovered in North Africa, probably Morocco. And they told me it had been spirited out of North Africa. It was bought by an Italian geologist who eventually decided to donate this partial skeleton to science, and that's how it ended up in an Italian museum. And they suspected that this partial skeleton belonged to Spinosaurus, this, incredibly rare dinosaur that I had been dying to find, And when I looked at the bones, they were laid out on big tables, my jaw just dropped, there were big, tall spines, hip bones. It was crazy, and we were very excited. We thought maybe after all these years, we finally have a new skeleton of Spinosaurus. But we also knew that we had a big problem because my Italian colleagues did not really know where this skeleton had been found. And if you don't have that information, then your fossil skeleton loses a lot of its value scientifically, because you don't know anything about the environment this animal lived in. This is information that is written in the rocks. You also don't know how old the fossils are. Perhaps most importantly, you also don't really know if all of these bones belong to one animal. Maybe they are found in a place with lots of bones from different animals that got, mixed together. And we also strongly believe that this skeleton should return to its country of origin. We wanted to do the good thing. But again, how can you do that if you can't really prove where exactly it came from? So it was a big problem. And up to that point in time, nobody in the history of paleontology had been able to retrace the actual dig site for one of these commercially acquired fossils. But then I picked up a chunk of the spine and I looked at it, and I suddenly had this moment where I realized that this chunk of spine looked exactly like the strange bone I had seen in this cardboard box in Morocco. It had the same size, texture, color. The inside structure was exactly the same, very dense bone with a strange, enigmatic reddish line running through the middle. And I thought, hang on, maybe, I know this sounds crazy, but maybe these bones here in Italy and the bones I saw in Morocco belong to the same skeleton, the same animal, the same individual. And I thought maybe what happened was that, the local man had found a few bones and he gave them to us in this cardboard box. And then he returned to the dig site and found many more bones, and those ended up in Italy. And I thought, if that is true, that's a big if, but if that is true, then maybe I can figure out where the dig site is. And who knows, maybe even find more bones. And I thought, in my naivete, I thought, the only thing I need to do is relocate that man. So I had to find this one man in the Sahara. It was like looking for a needle in the Sahara. And so I traveled back to Morocco and I met up with Samir and my British colleague, Dave Mathill. And I remember when I told Samir about my plan, he thought, well, I think both Dave and Samir thought, well, this is nice that you're trying, but, obviously we're not going to find him, And, Samir asked me, do you have his name and his phone number, his address, anything? Like, how are we going to find him? And that's when I said that, well, we know one thing. And I remember this very clearly. The man had a mustache. And that really didn't narrow things down much. But we decided to we had to do it. And I can be very stubborn. So I said, I have
find
to
the mustache man.
Yes. And so it was a crazy mission impossible. And we traveled to these remote places where some of the local people are digging for fossils. They dig these long tunnels into the rock, looking for isolated teeth and bits of bone. They didn't know anything about the man we're looking for. They certainly didn't know anything about an associated dinosaur skeleton. They said that's unheard of. And it was, in my mind, it was almost inevitable that we were going to find him. And it's only on the last day of our search that it sank in that this might not actually happen and that this was a crazy idea. And I had put so much hope into this idea. It sounds so naive, but that's how my brain works. I always, figure some way out to make something happen. I always go like, so I just see the goal and that's it. You're kind of very focused on that. And so now I was suddenly in a situation where I felt completely helpless. I thought, this might not happen. This is not going to have a happy end. This story is not going to have a Hollywood ending. It's going to have an ending like a depressing independent French movie or something. And so, oh gosh! And so we're sitting on the last day in this cafe and sipping mint tea. And, I was this close to throwing in the towel, giving up. And at that moment, a man walked past our table, and I just caught a glimpse of his face, and so did Samir. And we just looked at each other. It was just like, are we hallucinating, or was this the guy? And so, you know, just a few moments later, we realized, yes, this was the man, and he recognized us. And, you know, it was just crazy. It was so surreal. And he told us that, yes, he had found some bones in this dig site, and he gave them to us in the cardboard box. And he said he then returned to the dig site and found many more bones. And he said, I sold these to an Italian man.
Oh, bingo.
Bingo. And then, you know, the next part was I had to convince the man to take us to the dig site. As far as he was concerned, he was done with it. You know, he had spent a couple of months digging. It's really hard rock. And, you know, but still, this is a pretty special place because it's very rare to find fossils like this. But I explained to him that, you know, I'm not in this for the money. I'm not a fossil dealer or collector. I'm a scientist. And for me, it's really important to know where this fossil was found. And I also thought, you know, I am going to try and see if there's more of the skeleton there. And, you know, and I did say I wanted to return these fossils to the country of origin. And so he agreed to show us. And when we got to the site, we found bits of bone, which again had all the telltale signs that matched the ones I had seen in Italy and in Morocco in the cardboard box. And and then we started a series of expeditions over several years. And we found pretty incredible things. But probably the most exciting things we found in 2018 and 2019. And that's when we realized that this dinosaur was not just a really cool skeleton of a very rare dinosaur. We realized that it would rewrite the textbooks.
So why? How are dinosaur textbooks been rewritten?
I was hoping you would ask that. So
no, I was just listening to you. Just keep talking. I'm fascinated. Just
well,
go on.
What we did is we excavated. So we had some parts of the skeleton, but one really important piece we were missing was the back half of the animal, or let's say the tail of the animal. And in the other bones, we saw some really interesting clues that suggested that this animal spent a lot of time in the water, which was a pretty radical idea, because we paleontologists think of dinosaurs as land-dwelling animals. Some of them took to the air, and you know we can talk about it later, but we know that birds are actually dinosaurs. They're direct descendants of the dinosaurs. But there was this well-established idea, or you could say dogma, that dinosaurs did not invade the aquatic world. And so...
Wait, so there are now and then discoveries in Morocco of big, like the huge fossils of aquatic, do you say aquatic animals? Those are not dinosaurs.
Those are not dinosaurs. So we find big animals that are actually more closely related to lizards, animals like mosasaurs, those are marine reptiles. We find plesiosaurs with long necks. They look a bit like what people imagine the Loch Ness Monster.
Oh, yeah.
Loch Ness Monster would look like. So there are other groups of marine animals, but they're not closely related to dinosaurs. And so dinosaurs, that was really in many ways thought to be one of the weak points in the reign of dinosaurs. They were so dominant and successful, but they never quite managed to invade the aquatic world. And
so the standard model of the evolution of dinosaurs is that they branched off land animals, right?
Yes, they started off as land animals, and some of them took reptiles. To the air. There are many different reptiles around when the dinosaurs kind of took over the world. And the dinosaurs were just one of those groups, but they were land-dwelling animals, and they ate land-dwelling animals. So when we initially suggested that this animal spent a lot of time in the water based on its crocodile-like snout, its conical teeth, which are great to catch slippery prey, its dense bone, which would have been useful in buoyancy control in the water, its webbed, possibly webbed, but its wide, flattened feet. So we had a lot of circumstantial evidence, and we made this case. But you know, there was some pushback, partly because one of the things we were missing was a motor, if you like, a propulsive structure that would actually move this thing through the water. And so we had very convincing evidence, but it did bug me that we didn't have something like a specialized tail. And sure enough, in 2018, we started finding tailbone after tailbone of Spinosaurus. And it was really exciting. But I remember very clearly the moment we realized that this was something really, really special was when we excavated one of the tailbones located near the end of the tail, near the tip of the tail. And it had this really, really, really long spine, a ridiculously long spine. We had never seen anything like this in any other dinosaur. And, you know, on our team, we have, you know, leading experts in anatomy and paleontology. And we were just looking at this and we're like, what? This is, you know, this is utterly bizarre. We couldn't quite imagine that, you know, we're actually looking at a tailbone with a spine that was just so ridiculously long. And
so do you find these bits and pieces near each other, or do you have to play a puzzle game to
in some cases fit pieces together? But in this case, we just had the tailbone and there's this long spine. It's all all there. Wow. And we found, you know, so many of the tailbones. And so as soon as we started to actually put it together in our heads, at least, we thought, you know, this looks like a giant paddle, like a giant fin, something we've never seen in a dinosaur before. And sure enough, when we actually put everything together in the lab in Casablanca, it was just, you know, a wonderful moment, because we realized that we had found the propulsive structure that would move this animal through the water. And we knew that this would really change the way we look at this dinosaur, but it would also open up a whole new window of ecological opportunities for dinosaurs, right? Who knows how many other essentially aquatic dinosaurs we might still find in the future, or we misinterpreted in the past. You know, I think one of the things we'll do now is look at other fossils that are potentially largely aquatic dinosaurs. And so that was a real game changer. And that's, as a scientist, that's what you want to do, right? You want to make discoveries that really challenge the status quo, right? Discoveries that really change the way we look at these animals. And I think in the bigger picture, this discovery also serves as a reminder that we really don't know all that much about dinosaurs. We sometimes think we do, but if we miss something like a tail-finned back dinosaur that was hunting car-sized fish in a river system, and it's the longest predatory dinosaur, you know, what else did we miss, right?
Yeah.
And it also, I think, serves as a reminder that Africa, in particular the Sahara Desert, is still full of, you know, undiscovered treasures. And the Sahara is a big place. Many people here in the US don't really know how big a place it is. And in fact, many people in other parts of the world probably don't know. But when I ask them, how big do you think the Sahara is? I often get the answer, Texas, right? Because Texas is supposed to be big. Everything is bigger in Texas. And yet the Sahara is about the same size as the entire continental United States. That's a really, really, really big place. You know, and so these ancient river deposits we find in Morocco and all the way to Egypt and everywhere in between, you know, Tunisia, Libya, Algeria, are, you know, spread out over a huge area. And so, you know, this is really has been one of the big geographical, you know, focal points for our research. And
so can you find fossils? Do you need a specific type of terrain for you to be able at least to look for fossils? For example, on sand dunes, can you look for fossils?
No, but I think one of the things that one of the, I guess, misconceptions some people have about the Sahara is that it's just rolling sand dunes and, you know, but a high percentage of the Sahara, I would say between 60 and 70% of the Sahara is actually rocky, right? And you have these big plateaus, hamadas, the Hamada Kem, for example. And so those are the places we look at. But some of those places are very difficult to access. They're very remote.
Yeah.
There's we're working in the Moroccan-Algerian border region, so we sometimes have a military escort because we're so close to the Algerian border, and it's not an easy place to work in, and that's one of the reasons why Africa is underrepresented. It's just logistically pretty challenging to work in parts of Africa.
So in the Sahara, sorry, go ahead.
No, go ahead. You can ask your question.
No, so if you look at the map, you basically have Libya is at war. So Morocco is probably one of the best spots with the logistics to do these finds. Algeria, maybe second place.
Yeah, Algeria is a very interesting place, and I've been in contact with Algerian colleagues for a few years now. Again, some parts are very remote, and there's one of the problems we're facing in different parts of the Sahara is that there are armed groups operating, right? And so and that's true for a number of places, including places that are kind of on the margins of the Sahara, like Niger. I did some fieldwork in Niger, and we had over 30 soldiers and gendarmes as an escort. It can be logistically pretty challenging for those reasons. Libya is obviously a bit of a problem now, but it is challenging. But I'm planning to visit and explore many of these places because the scientific gains are just so big, right? It really allows us to fill some major gaps, and that's something, as I said, I always wanted to do. So, but it really does push you to the limit.
And how is the technology of exploration progressing? Because as you say, it's very hot there. Are there people thinking about things like suits or things that can ease the exploration work in this arid environments?
A lot of what we're doing is still very similar to what Stromer would have been doing when he was doing his over 100 years ago. Right. For the simple reason that yes, maybe in Stromer's time he was using camels, and we're using all-wheel drive vehicles, but we don't really have any super devices that can tell us where the fossils are underground. We're using satellite imagery. We're looking at potential places to explore, but at the end of the day, once you're there, it's just your backpack, your water bottle, your geologist's hammer, and your legs, right? And then you're out there, and it's really challenging. It's but at the same time, it's a magical place, and I think we are very privileged to explore some of these places, especially the ones that are located in military zones where nobody else goes, right? They are places of really outstanding beauty in some ways, because it's a place where especially when you're in places where there's no internet and no phone and you're just out there, and it looks like everything is so big and so vast, and everything is reduced to the most important things, and your entire outlook is very different. It's about you have to count on your team members. Water is very important. Things that you take for granted in your normal everyday life suddenly become very important. So it's a pretty magical place. It looks like a timeless place, but of course, as a paleontologist, you can do this amazing thing, and you can become a real life time traveler. So you pick up a tooth like the one I showed you earlier on, or here's another dinosaur bone, and you look at this, and you look at or a fish scale. Fish scales are a really great example. You look at a fish scale, and you're in the Sahara. It's hot, you're thirsty, you're dry, everything is dry, and there's a giant fish scale in your hand. And so in your mind, this place comes back to life. You see this river system, you see this giant car-sized fish, all the other things you found, the crocodile-like hunters, the dinosaurs, the flying reptiles, and you get to travel back in time, and it's pretty amazing and pretty magical.
You know, this kind of vision that you had, I'm thinking of the first humans that this struck them, you know, that like a wake-up call. I think I read about some the early scientific maybe this was in ancient Greece as well, but there was at some point people wondering what the hell are these fish fins doing on the top of a mountain? You know, rivers don't flow upwards, you know.
Yeah. Well, I think sometimes for now we take these things for granted, or at least in parts of the world we do. We go to museums and so on, but you know, this was a huge thing. So, for example, when many of the really important early discoveries of dinosaurs were made in England, and at the time it was just something so radical. You know, when they put together the first reconstructions of these animals, and you can still see some of them at Crystal Palace. It was just, you know, most people assumed that our planet was just a few thousand years old, and the idea that there were these lost kingdoms, if you like, from a time when reptiles ruled our planet, and it was just wild. It was just crazy.
I'm sure the earliest they could push this in their mind was like, oh, maybe it's not 6,000, but it's maybe 20,000. But dude, you're so wrong.
Well, there's that, and also I think just the idea that our planet has this very long history where we just didn't play a role. We were not around, you know. And of course, even now, I think it's pretty incredible to think that, you know, when dinosaurs ruled our planet, you know, our furry little ancestors literally lived in the shadows of the dinosaurs, you know, and mammals only got their lucky break when, you know, the forces of nature and a meteorite, you know, conspired against the dinosaurs. So
that's right.
It's really pretty amazing.
How did these ancient curious people interpret these fossils? Do you know the history of this? Did they think there was
in different ways? You know, sometimes there are funny names that people used to give to fossils, and so ancient shark teeth, and I've got some. These are really big ancient shark teeth, but they used to call them one. They used to call them tongue stones, like a tongue in your mouth. A tongue stone, and you know, it took an early comparative anatomist to figure out that these were actually shark teeth, right? So you say, well, these look like shark teeth. They're shark teeth from, you know, ancient times. Sometimes people would find dinosaur bones and interpret them as the bones of giants. You know, there are all kinds of mythological stories about giant humans walking around. And, there are all kinds of interpretations, you know, that people came up with. But of course, the reality is more amazing and more awe-inspiring than anything we could come up with, right? So it's one of the beautiful things about science. You know, I think some people try to complain that science kind of takes away the magic, but I would strongly disagree. I think science actually, you know, shows us these stories that are so much more awe-inspiring and breathtaking than anything we could possibly come up with. And
there are so many. Maybe you can tell us about some of the awe-inspiring creatures, things that surprise any Pegasus and any, you know, those Greek monsters or monsters that any civilization had invented. You know, I know this big mammal, the crazy big insects. There was an epoch where every insect was magnified. Oh my God! If you travel to that era, you would be like, it's awe-inspiring.
If you go to Morocco, there are many people who khafum les cafards. If they were in the time where they had like giant dragonflies with a massive wingspan, that would be their nightmare, I think.
It's crazy.
So there's certainly times where you know, I think size is certainly one factor. Some of these ancient animals are really absolutely massive, but it's not just their size. One of the groups of animals I'm working on now are of the pterosaurs, flying reptiles, and sometimes also known as pterodactyls, right? And they are reptiles. And yet, when we think reptiles, we think, kind of sprawling, relatively slow moving animals. And yet these were magnificent flyers, right? And some of them had a wingspan of 10 meters, right? Absolutely amazing.
Wow.
And so you
Wait, so this is 1.5 meters?
Yes. So just
So
imagine an
oh
animal with a wingspan of 10 meters. Some of them, when, you can find some images on the internet, when they're standing on the ground, they would fold their wings and they would stand on all fours. They would be as tall as a giraffe. So just think of an animal as tall as a giraffe, and it takes off and flies into the sunset, and that's really, these are impossible animals, and yet here we are, we have their fossils. They're clearly not impossible. And that's kind of part of the fun of paleontology. You get to resurrect these creatures, and you have to figure out how they were put together, how they flew, how they reproduced, what kinds of eggs they were laying, could the little ones fly off or not? And there's just so many things you have to figure out, and there's no, manual, there's no assembly instruction, and you have to use so many different disciplines. You use anatomy, but we now also use, we use CT scanning to look at the inside of fossils. We use modeling to model the movements of these animals. So it's, cutting edge technology and anatomy and all of these different things. And so, becoming a paleontologist is not easy. And certainly, your things like your job prospects are not like, being a pharmacist or an engineer or something, but my goodness, when you're actually doing this work, you get to experience things that very few other people can experience. And for me, bringing together all of these scientific disciplines to essentially, it's an act of creation, as one of my colleagues put it, to breathe life into an animal that lived 100 million years ago and figure out all of its anatomy is incredible.
Yeah, that's right. And while listening to you and while imagining the time span of life on Earth, these crazy animals that roamed on this planet millions of years ago, what I think of is, I think of this childhood imagination and exploration inside the mind of a child that very often gets lost through the life of most people, I would say, through their educational process, and maybe the people get married and they just forget about these things. Yeah. So maybe this could be an entry point to talk about our final segment, which is more about how can we keep this curiosity in the minds of of people, not only the youth, but how can we prevent this massacre that happens to the imagination of people as they grow up?
That's a good question. I think, I would say all of us, or at least the vast majority of children, are born scientists. They have this incredible curiosity about the natural world. If you put a very, very, very young child out into nature, they want to, touch things and find out what things do, and they'll be very interested in, watching animals and so on. And unfortunately, and I really find it hard to understand why this is, but in our educational systems, we put so much emphasis on all kinds of other things, but somehow we can't make time for, natural history and science, real science. Science in schools is often just learning things by heart. Oh, here's the cell cycle, and here's photosynthesis, and it's very dry. And it's, and if that's your idea of how science works, or biology, for example, then yes, you're not going to want to become a scientist, and you're going to shut off that part of your imagination and your brain in some ways. But of course, science is really a whole approach to exploring and interpreting the world, right? And there's so many incredible discoveries, and we talked about some of them today. And, you know, some people kind of rediscover this interest in science, and maybe one day they'll walk into a natural history museum and see a towering dinosaur skeleton, and they'll just stand there in awe, and this little spark of curiosity is going to return, right? But then often it's too late. And I sometimes meet people that tell me, oh, you know, when I was young, I wanted to become a scientist, and then, you know, people told me, no, don't do it, and, you know, and then they regret it, right? And that also happens. But it's a really big problem, and it takes there are many different aspects to it. And so I don't know, if we talk about Morocco, for example, I think education is one thing. I think scientific literacy is another aspect. I think there's also a tendency to kill off much of the interest that children have in animals. You know, I think many kids growing up in Morocco, you know, and I see this, are told that, you know, oh, don't get near this animal, and then they're dirty, and this animal, this and that, and all these kind of superstitious ideas about, you know, it's kind of something dangerous and something, you know, dirty, and something you shouldn't really get too close to. And this is reflected in many different ways, you know, and it's a big problem. And, you know, I mean, it's really difficult. If you're interested in animals, and if, you know, care about animal welfare and other things, it's difficult to go to Morocco. It's a really tough place. And so I think, you know, there is now some focus on protecting, say, you know, water, and making people aware of the importance of certain ecological narratives, right? But it's not really that there's a real plan to make sure that people are scientifically literate and have access to scientific, you know, content, and which is why I think it's great what you're doing. But ultimately, you know, it's also down to things like the lack of cultural institutions like museums, and you know, there's no real natural history museum in Morocco, which is crazy, right? We talked about the incredible ancient heritage Morocco has in paleontology. You have everything from some of the oldest fossils in the world to, you know, dinosaurs, to very old remains of humans. You have, you know, you name it, it's there. You know, you mentioned marine animals. There are ancient whales that are found and have been described in recent years. You could fill a giant museum with just these Moroccan fossils. And I sometimes...
Trilobites.
Morocco is famous for fossils. And it would be a little bit like wandering around Egypt and finding out that they do not have a museum of antiquities. You know, they don't have any museums displaying Egyptology, right? You'd say like, what? You know, you're famous for this stuff. They do not have a museum. And in Morocco, it's a little bit like that. So it's something that I'm trying to push for, but it's difficult because, again, it's kind of a vicious circle. If people do not really have much exposure to science, people will see this as very low on the priority list. Why should we have a scientific institution or a natural history museum? And so it's this very dangerous, vicious circle, leaving aside the fact that natural history museums in many parts of the world are major tourist attractions, right? Some of the most visited museums in the world are places like the Natural History Museum in London or the American Museum of Natural History in New York. And if you had a natural history museum in Morocco with Spinosaurus on display and a whole bunch of other things, it would be a huge draw for tourists, right? Especially if you had it in a place like Casablanca, which is in many ways a cultural desert. Right? There's very little to do, and so I think it's wrong and dangerous on so many levels, but it's difficult, you know. And I think ultimately you really need some support and at many different levels, and you know. So I think people like you are fighting this pretty lonely battle. And, trying to change.
I think there is a community. I think there is a growing community, and I mean what I'm saying because I see it in social network. It has been empowered a lot by the internet. The internet has created this spark of new communities that really share this passion and this interest. And I think this small community is going to grow. Maybe someday it will pay for the museum, because one question is who pays for the museum.
That's what I was going to say. I think that there's some truth to that, because I'm getting messages from people in Morocco, and people certainly have an interest when you look at young people that have a scientific background and so on. But as you said, that's kind of, it exists in the internet, but in terms of what we create, in terms of tangible results on the ground, we're still kind of at square one, right? And so, yes, my hope is that things change and that it becomes a generational kind of change, right? But it's, and of course, it's not a problem that's unique to Morocco. I think that in other parts of Africa, it's very strange. I think we really need to make sure that ancient history, so that does not just include very ancient history like paleontology, but also archaeology and so on. These stories need to be told, right? I think there's often a big focus on, the here and now and, business and what have you. But I think it's very important for the soul of a country to have places where people
there are these call them maybe creation stories or of a nation. I'm talking in the creation story of a nation in this sense. But in most, I think in Morocco is an example. In most countries of the region, they go back to a couple of thousand years ago, while they could go back to 14 billion years ago. Not just the fossils, but there are meteorites that are found in Morocco. So I think you can have a natural history museum that spans the whole history of the universe. And when you were talking about the museums, there's something I tell myself: if Morocco doesn't have a museum for Jebel Irhoud man, then there's nothing else you can. I mean, this is the story you can tell around this fossil is this is the most ancient Homo sapiens or archaic Homo, or something that looks like Homo sapiens enough to be called Homo sapiens that is known today. So this is you can tell a story that unifies the whole mankind. I mean, the emergence of Homo sapiens, one of the spots was Morocco, this same land where the museum probably is built. So yeah. I don't understand. Honestly, I don't understand.
I mean, you can tell a number of stories. When we look at very ancient, archaic Homo sapiens, I mean, we have a number of locations in Africa where you can find these very ancient remains. This is one of the very ancient ones. But I think this isn't a pretty neat story. But I would actually argue that there are other stories you can tell that are in some ways even more profound, right? And this big story of life on Earth. You could have a giant gallery that takes people through this entire history. The thing with archaic Homo sapiens fossils is that there are a bunch of them from different parts in Africa. Many of them are very old, and you always find an older one somewhere else, and so this is something that, but the whole package, the entire fossil record of Morocco is something that really is pretty incredible. I mean, there are other places in the world where you find amazing fossils, but not that many, right? It's one of a handful of countries that really has this kind of unbroken record for various geological reasons. And it's frustrating to see how, some of these fossils end up all over the world, but not in Morocco, and that's actually a complicated story, because it's not that easy to just say, well, we'll just, I mean, we have put all our fossils into a collection in Casablanca, but it's not that straightforward, because, as a scientist, I also have to make sure that my fossils are looked after and safe, or ideally many hundreds of years, right? And so, and that's, you know, the reality is that it's really challenging. I think everybody is clapping and happy when you tell them, oh, you know, we have repatriated this particular fossil to its country of origin and what have you. But the reality is there are many challenges. You know, there's corruption, there's, you know, a lack of funding, there's, you know, infrastructure. There are all kinds of things, you know, and we've seen that this can be, you know, really challenging in developing countries. You know, I mean, we saw the loss of ancient treasures in Iraq and Syria. We saw the recent giant fire in Brazil that destroyed the National Museum there, which was an amazing place, but it was completely underfunded. And, you know, so capacity building in developing countries is actually quite challenging. You know, just bringing the fossils somewhere is just the first step. I mean, you really need, you know, support from many different levels. And that's,
you want to put the spotlight a little bit more on the, well, it's the opposite of the spotlights, because I want to draw the dark picture before we can talk maybe about ways to get out of the situation. But I have heard many stories of fossil trafficking, basically. I heard a story of a van that was full of fossils that was I think checked somewhere in the borders, and somewhere told me he saw it in Spain, basically a big van that was came out of Morocco. It was full of treasure. I'm sure it was treasure. I have no idea what species were there, and I'm sure you heard about stories like this. So how bad it is?
Well, this is kind of an interesting you know, topic, because when you look at it, in some ways you can say that, you know, there's a real kind of the country's kind of bleeding out, right? It has all these amazing fossils and they all disappear through various channels, and that's just because there's no real infrastructure. There's a lot of corruption. The legal framework is kind of shaky, and it's tricky because there are different components to this story. I think when you look at fossils, I think that individual countries need to have museums and places where they can tell their story and show their amazing finds. If you don't really have that infrastructure, it's very hard to tell people, keep the fossils here, right? If there's no museum, it's really difficult, right? And so some fossils end up in private collections, which can be very problematic in some cases. Some end up in museums elsewhere in the world. And from a scientific point of view, this is a tricky one because, you know, some fossils end up in, you know, Japan or the United States, and they're in places where they are looked after and they're kept in very good conditions. And I know stories where fossils were returned to developing countries and they just fell to pieces because nobody was looking after them, or they ended up being sold on eBay. All those things actually happened, you know. Okay. So there is, you know, we are trying to work very hard to make sure that Morocco can display its incredible ancient heritage. And, you know, we have fossils of ancient whales that my colleague in Casablanca excavated. We have dinosaurs, we have all kinds of things. So, but when we go out hunting for fossils, we also see some of the local people in very remote parts of Morocco digging for fossils for a living, right? And that's the only source of income they have. And, you know, to just say, well, shut everything down and not let people excavate any fossils is also not a solution if you can't offer them alternative sources of income, right? So you can see that this is not really a black and white issue. It's very, you know, there are many different aspects to it. So I think what you need to do is find the right balance. And different countries have different legal frameworks, but in some parts of Germany, for example, what happens is if you find a fossil, people will evaluate whether it's scientifically important or not. And in some cases you can keep it. In other cases you will actually, it will go to a museum collection, and, there are all kinds of processes in place. That's kind of an ideal situation, right? In Morocco, I think we still need to do a lot of work to figure out the best way to do this. And, if we look at other countries, I mentioned Brazil earlier on. Brazil had some very kind of draconian laws to make sure that Brazilian fossils stay in Brazil and are not exported out of the country. And the motivation behind some of the laws in some cases was not a bad one. But as we saw when the National Museum burned down, I think now every scientist is happy that some Brazilian fossils were actually in collections in, Germany or Japan or, the Netherlands. And so I think, ideally, you still want to have some Moroccan fossils in other museums, because science, as I said, doesn't really have any borders, and, there are different agreements, and some fossils are very rare, others aren't. There's some fossils that are very common, and there's no reason to keep them all in Morocco. Others are very special, like the skeleton of Spinosaurus, and you really want to make sure that this is put on display in Morocco. So it's a messy problem in many ways. But what I will say about the fossil trade in Morocco is that it is, a reflection of, the problems I mentioned earlier on. And we see the same thing in places like Egypt. And again, you can say, well, should all Egyptian artifacts stay in Egypt? Large numbers of artifacts from Egypt have also disappeared on the black market. And, it's challenging. What I'm seeing now is, I think, a new generation of scientists tackling this problem. And so, mentioning Egypt, for example, I have a great, fantastic colleague in Egypt who is working very hard to tell the story of Egyptian paleontology. And he established a great lab and collection at Mansoura University in Egypt. But, he got some of the support he needed. They have a really modern lab. So even in developing countries, it's doable, right? And so that's kind of what I would like to see in Morocco, a little more support to establish real professional collections in different universities in Morocco. And once you have that, you can start to tackle the bigger problem of fossil trade and so on. But, right now, our collection in Casablanca is really, it's probably the largest. And, we're really struggling. We've got zero support at the local level. We're hoping to make something work with the university, but we really need to make sure that we have these professionally curated collections in Morocco, so that we can tackle the bigger problem of the kind of bleeding out of fossils that's happening in Morocco.
It seems to me that it's there's two sides of it. There's the institution side of it, and there's the the capacity building, as you call it. The professionals, the universities, the structure, the legal framework, and so on. And then there's the engine, which is the interest of the people as a whole in all of these things. In terms of the first one, before maybe we move to the second bit, the first one, the capacity building and so on. How do you, from your collaboration with your colleagues in Morocco, is there a community of scientists, researchers who have this mindset, at least the mindset? Because I know there is a huge problem of funding of financial, basically very basic financial problems. I think it can even come down to the salary of a researcher. It's very different from as a researcher in the US or in Germany or in the UK. But at least in terms of culture, is there a community in Morocco that has this real deep connection with the science, with the actual science, independently from the actual administrative rankings within the university and all that? It's other things.
Well, I'll be honest. I think, there are some people with, a lot of motivation. And, my colleague, Samir Zuhri in Casablanca is one of them. People that are really trying hard to change things, publishing papers, trying to get research projects off the ground. But the reality, as I said, I think when we're talking about this, we shouldn't, we have to talk about the things, honestly. And I think, when we talk, for example, about the problem of corruption in Morocco, we also have to say that, there are many university professors in Morocco that are spending very, very little time with actual research. Many of them actually barely turn up for work at university, and they earn their money or additional money teaching in private schools. That's very common. It's just a reality, right? And so I think, yes, there are some real weaknesses in terms of research infrastructure and so on. I think that's real. But I also think that we need to make sure that the scientists play their part, and some of them work, and you've interviewed some of them, I'm sure. Some of them work incredibly hard to make things happen, to publish in high-ranking journals and so on. But they are in a minority, right? And so I think, I don't know if I would say there is a community, it's really little islands of where things are happening. But it's not easy, I think that there is, and there are a number of reasons for this, but I think that when you look at academia in general, I think there are a lot of things that need to be addressed. And some of my colleagues in Morocco also sometimes point to Tunisia, which is a much smaller country, and somehow they still have a higher publication output, So, even compared to, comparable countries, I think there are things that really need to change. And so one of the things we're hoping to do with our research is also, motivate others to kind of contribute to this work, and to do more work on the public understanding of science in, the Maghreb, and doing their bit to kind of keep research output at a relatively good level, So yes, the means are often, often the possibilities are limited, and, scientists are lacking some important funding and so on. But, a lot can be achieved, and there are people that show that it can be done, right? And I'm sure you know them, right? So I think that's also something that we shouldn't just neglect, and because I think there's also sometimes this tendency to just throw up the hands in the air and to have this victim pose where we just say, well, we can't do anything anyway, and we don't have any money. And it's, I think that's certainly part of the story, but there's some really big things that need to change in academia and research.
Yeah, so I think it comes down again to the bigger picture, which is the society, because people don't do the things they do professionally only for the salary, as you mentioned. If a scientist, when they sit down in a ars, in a marriage wedding, and they talk about what they do in the lab, and people get excited, and it's a topic of praise to what the scientist does, then it's a huge game changer. But if you're in a society where you sit down and you say, I've discovered the Spinosaur, and then people just say, keep talking about something else, then you lose. It's a very different situation professionally, and people want meaning in what they do. So I think if there is this small snowball that keeps growing, which is public interest in science, then on the long run, it can only empower the islands that you mentioned, the small communities or individuals that have, that share this passion for real science.
Well, I think what you're saying is very true. I think, and that's where museums can play a really important role. To use an example that some people can maybe relate to, because you mentioned, BBC natural history documentaries early on. These have these generate so much interest in the United Kingdom, right? David Attenborough is like a god, right? I mean, he's just, I think was voted the most popular Briton. And so I think there are some real differences there. I think if people don't have this scientific curiosity and this connection to the natural world and science, yes, the thoughts revolve around careers and money and, who has the more expensive car and who went to the more prestigious school or whatever. And, that's something that I did notice, sometimes you try to talk about some of the things you do, and it's almost like it's not really registering, it's not really connecting. Right? The people kind of go like, oh, okay. And then they hear about someone's latest vacation. They're very animated and go like, oh, really, how much? But did they get a good deal? And you go like, I just told you about the discovery that made the cover of the world's top scientific journal, right? Or, I just told you that, I just tried to tell you about the history of life on Earth, and you're talking about the latest. So I think that is certainly something that will only change when a lot of other things change. But I think there is, as I said, a really important first step would be to make sure that we at least try not to lose the young generation and make sure that natural history and biology and all of these topics do not become distant concepts for them and things that they have no interest in, right?
Yeah, you're right. And so you mentioned like when you're in a social setup, and I think the people, as an anatomist, you certainly know, we are an emotional creature. So things that have an impact on us emotionally are the things that we will keep talking about or keep connecting around. And so people who have never felt that deep emotional link with the universe, or with things like the deep time that we talked about earlier today, if they have never been exposed to these deep ideas that shook them internally, then they would just say, oh, whatever, the cover of National Geographic, whatever. But if they have been exposed to that, then yes. So I think so maybe the few elements are, as you say, the public institutions like museums on one side, but also the educational system on the other side, and the way science is taught, because we don't teach the scientific method. I don't think we do. I think there's probably a class or a course or two in the curriculum, but it's not really taught. And we don't teach also what science teaches us about us and about the universe. This kind of concept, like this emotional thing about things like the deep time, or when you look at the stars and you figure out that every single dot out there in the sky it's another world with other planets. These kind of emotions are not highlighted in the educational system. So I think there's probably, I see hope, at least in social networks and on the internet. But it's really a process, and it's a snowball that if you don't maintain it, it will die out. Because I also see on social network forces that are against this in a way or another. And we talked earlier about evolution. There are folks that every time I write a post about a discovery in evolutionary biology, they will attack you. Mm-hmm. And maybe, I don't know, there's a bigger framework than evolution, but it's the way the mind is wired in the whole society, and the way they look at the world is sometimes not compatible with the way a scientist would look at the world.
I think there's certainly some truth to that. I think one of the things that people can relate to, if I tell people, I teach students going to health professions, human anatomy, that they understand. You go like, oh yeah, like your doctors and so on. If I then try to tell them how the human body reflects ancient evolutionary structures changing through time and so on, I've lost them, right?
Yeah.
And so I think that, the concept of evolution is still strangely controversial in some parts of the world, including in some parts of the US. But of course, we're now at a time where this is not, some sort of divergence of opinions or so. We live in a time where we can literally quantify the differences, the genetic differences between humans and chimpanzees.
Wait, let me ask you this question, Nizar, so that it's officially on record, because there was a major news outlet a few years ago that announced to the world, it's a golf news channel. They announced to the world after the Ardipithecus discovery in was it Ethiopia. They announced to the world that evolution has fallen. سقطت نظرية التطور. It has fallen and it has been discredited from the universities of the West. So my question to you, Nizar, has evolution been debunked in the universities of the West?
I have no idea how they came up with that headline, but no, of course not. I think, as I said, everything we do in the biosciences happens in this framework of evolution. When I teach the human body, it's the result of a process of evolution. When we look at the evolution of viruses, for example, as we do right now, we're in the realm of evolutionary biology. If we try to piece together the history of life on Earth, this is obviously the big story of evolution. The distribution of animals in the world, the presence of strange vestigial structures in different kinds of animals, including humans. We have the remains of a tail, and some babies are actually still born with a tail in humans. That's something my anatomy students always find very interesting. You can't think of anything that doesn't require a thorough understanding of evolution in the biosciences, right? And as I said, we're now at a point in time where we're seeing this overlap and interconnectedness. Evolutionary development, for example, is a huge field looking at developmental biology and the origin of major structures. So, for example, one of the big things is the human hand, right? We look at things like the transition from fins to limbs in the paleontological record, but also we look at the developmental steps, right? How do you turn a limb bud into fingers, right? And so you suddenly see how paleontology relates to medical issues like syndactyly and which is different digits fusing together, and we are now in a time where all of these things are very interconnected, right? And so evolution is at the core of all of this. So it's really strange because it's based on so many different lines of evidence. It would have to be a conspiracy of astronomical proportions, because geology and biogeography and genetics and comparative anatomy and paleontology and all of these different disciplines are
the fossils are there in the museums, and the genetic code is there in the libraries. People can actually look at and touch they are there behind you, right? And in the boxes around you. So how can you deny all this?
It's about as absurd as to claim that we live on a flat Earth. There's so many different lines of evidence that show us that we do not live on a flat Earth, that you would have to be, not quite sure what word to use, but let's just say it would have to take a very strange approach to the world to deny all of this evidence. It's right there, and it's available to all of us. And it's the same thing with evolution. I think. Yeah, go ahead.
No, the thing is, the overwhelming majority of these people are they simply do not know what is evolution. So it's a matter of literacy. And this is exactly the same thing with the flat Earth people. They have never read a book about evolutionary biology. And I'm sure we cannot make the case here. We've already had, I think we're way a little bit over 2 hours, and it would take us probably 10 hours to go through the case, the scientific case for evolution. It takes time. Those are constant. It's the same struggle I have with flat earthers. It's someone that tells me things about the density of air is what makes the shape of the horizon, whatever. The guy has no idea what he's talking about. So at first you need to understand basics of physics, and then let's talk about the shape of the earth. And I think it's the same thing for evolution. People need to take the basics. So I'm sure people who are evolution skeptics who are watching this, they will probably not be convinced just because you said that it takes a major world conspiracy for you not to believe, but it would take them education. So they need to learn the basics to see the evidence by themselves. And it doesn't take 15 minutes, it doesn't take 1 hour. So maybe we can recommend them a couple of pop science books. I don't know which ones have been translated to Arabic, but maybe if you have some titles.
It was always my my goal to put together a book on the paleontology of North Africa and actually have it translated into different languages. And one idea I had was to actually make it available as an ebook, so that, you know, even people in a remote school somewhere in you know, the province of Rashidia can still, you know, access it on their phone.
Yeah.
And I think, you know, and again, museums would play a very important role in that. There are some great popular resources. It's difficult to find one that really covers everything in depth. There are some great videos that people have put out there, but again, much of the content is only available in English, which kind of goes back to one of the earlier problems we discussed about.
Yeah.
But it's as you said, it's not something you can just fix in a couple of hours, right? And sometimes when I talk to people with such ideas, you just don't know where to start. They'll tell you something like, "Oh, but all the quote unquote missing links were proven to be fakes," or things. I mean, absurd things, right? And so, but you really have to take many steps back. I actually think, and maybe this is something we could do one day, I actually think that taking a look at the human body and its ancient evolutionary history is a good way to start. And so one thing, I think, one recent program that I think I would recommend to people is, I think it was on PBS. It's a program that was put together and presented by one of my former colleagues at the University of Chicago, Neil Shubin. It's called Your Inner Fish. And there's also a book that goes with it. I think there are 3 episodes. And this is a pretty good program that kind of starts with something everybody's familiar with, the human body. But then they find out
it's translated to Arabic, by the way. I know the documentary has subtitles in Arabic, and the book is translated to Arabic. So I recommend people to read it.
Because when you look at the evolutionary history of some insects and plants and what have you, it's really difficult for people to relate that to themselves, right? But when it's all related to the human body, as is the case in this documentary, I think that, you know, you see some of the major steps. And it's something that people can relate to for sure. But yeah, it's going to take some time. And again, you know, people like yourself and the community that you exist in is, you know, are very important. But yes, there are some very strong and powerful forces pushing in the opposite direction. And so I think, you know, it sometimes feels like an uphill struggle. But it will be interesting to see in a few years if your prediction is right, that this new generation is kind of tilting the other way. If it is, then I think this is great news. But if it isn't, then I think we're kind of fighting a losing battle. So I really, really hope that we are, you know, really changing minds. Because sorry, go ahead.
Yeah, no, as I think it was Neil deGrasse Tyson or I think it was him who said science works whether you believe in it or not. So the science ultimately it's true. So as soon as people learn, as soon as people read the books, then they can only once they understand something, that's it. I mean, once you learn physics, then that's it. You cannot say the Earth is flat. It's over, and the same goes for biology. So it's a struggle for education mainly. Even if there are those forces, I would say it's not. I wouldn't frame it as a battle between forces, but more as a single battle for educating people and to show them the evidence. It's almost as the image of Galileo Galilei when he was showing people planets in the telescope. That's exactly what has to happen in our modern societies for this, at least for our society, not only ours. The US is another big mess, and other places.
On a number of different levels. And actually this anti-science, anti-elite, anti-facts frame of mind is now really showing its ugly face, right? In the COVID crisis, I think, that's why it really does matter, and these people are voters, and if it's a slippery slope, and once people are convinced that experts have opinions and that's about it, they don't have any expertise, and their opinion is just as valuable. And if they believe that facts don't really matter and can be interpreted in a million different ways, then, anything goes, right? And the craziest ideas can suddenly become mainstream. And in the US, we're seeing this on a number of different fronts. There are all these big battles, if you like, when it was, whether it was evolution or, fluctuations
climate
in
change,
or GMOs, or now COVID. It always rears its ugly face, and so it's I think one thing that is true for scientists here and in places like Morocco is that we need to do much more to get people excited about science and exploration. I think many scientists, and maybe some you interviewed, are kind of living in their own little world, and they live in their bubble, and they're very happy doing what they're doing. But you can't do that anymore. You can't hide and say, I just care about my research. I don't want to spend time engaging with the public. You can't do that anymore. We're at a point in time where this has really become a very important problem. And I think all scientists need to spend, some of their time going out there and, holding up the banner of science. I think that's something we all really need to do. And it's not easy because we're very busy with so many other things. But, one of the reasons why I love working with National Geographic or doing TED Talks and so on is that this gives me an opportunity to reach millions of people all around the world and get them excited about science and exploration. And I think we really need more scientists, working on that front.
Yeah, that's right. And maybe we're nearing the end of our discussion, lovely discussion. Just to finish on an optimist note, on following up what we're talking about, I think I'm really optimistic because, the main reason I'm optimistic is that the whole civilization today is based on science. I mean, these people, how can you, okay, fine, you're denying the existence of COVID. Then what happens? Well, you're going to die at some point. So I think everything is based, the truth, you cannot hide from scientific truth because it's real. It's scientific truth is based on evidence. It will not go away if you don't believe in it. If you deny it, it will not go away. Saturn will keep its own rings, whether you believe in it or not. So I think just the simple fact that civilization is based on science. I mean, we could really mess up with civilization. We can mess up with the structure. We can countries. I think the US could go very wrong if this polarization and this anti-science movement keeps growing. But at the end of the day, science is there. It's the reason why mobile phones work and airplanes work and vaccines work. And even if people deny that the vaccines work, but at the end of the day, they do work. So I think I'm optimistic because I think that the battle can only be to the favor of science because simply because it works.
I think I certainly want to share your optimistic outlook, and I think this is a good way to end an interview. One thing I would add, though, is that while this is true, you said, well, the science is there, it's real. It is sometimes not very tangible or not something people can directly experience. So, for example, if you're talking about the overfishing of our oceans, it's not something most of us can actually experience, and including large scale changes in temperature, in climate. You know, there are things that kind of, or evolution, you know, which often happens on time scales that we cannot even begin to comprehend. And so, you know, people can still navigate life without really accepting any of these things. It's not always really in your face. That's, again, where education and museums come in. With education and museums, you put it in their face. So if you can just live your life with your human body and not care a bit in the world about why you look the way you do and why your body functions the way it does. But if you go to a museum and you stand in front of a, you know, cast of Lucy, Australopithecus, and you see all these other skulls, you see all the evidence right in your face, then that's very powerful. But I think that's the problem. I think, yes, science is real and it's out there and the evidence is out there, but all too often it's not really in front of people's faces, right? And so that's where it gets a little difficult, because yes, they'll be sitting on an airplane and they're doing this and that, but you know, as long as they don't have it right in front of their face in a documentary film or a museum or a book, it might just as well exist on a different planet. You know what I mean?
You're right. You're right. Absolutely right. So listen, what we'll do is if I go to the US, I'm definitely going to go to your lab, because I see so many bones that we didn't talk about. So you're going to show me around. And if you come to Morocco, please let me know. Let's do like social network stuff and stories on Instagram and so on together.
To visit the Spinosaurus skeleton.
Yes, and you know, we should promise each other to do another interview after the museum happens in Morocco. So,
well, okay, good while.
Let's see. All right. Well, thank you so much, Nizar, for this lovely chat.
Well, thanks for having me. Shukran.
All right. Talla.